Hello everybody and welcome back to the multiplayer project, where today it says we're doing NavNode Neighbors. I've kind of changed this name, although it's kind of the same thing. We're going to be working on map utilities today, if I can type it. There we go. So we are not going to need to mess with our pathfinding script. If there's any bugs in here, we'll find that out at a later time. We are going to need to work in the tile, and I believe we need to do some work in the map. Yes, we absolutely do. And we're going to do some work in NavNode, although not on the NavNode class. Let's actually begin there. So we've got our enum position in tile here, and we're just going to extend this with some extensions, or more specifically, one extension, because I want to be able to ask a direction what the opposite of it is. So if we don't necessarily know what the direction is, like we're passing in a variable, I'd like to be able to just programmatically figure out what the opposite is. And we could do this with some fancy number like remainder work or something like that. But we're just going to do a switch statement because we might extend this at some point in a way where it doesn't quite work, and it probably wouldn't because of our center anyway. So we're just going to do a public static class here, and this is just going to be navigation direction extensions. I cannot type, but we already knew that. And inside of this, all we're going to do is public static navigation direction. Oh yeah, that's right. I renamed this to navigation direction. We should do that. I don't like position in tile. I want this to be navigation directions. There we go. So this is going to be a public static navigation direction. It returns a direction. And we're going to call this opposite. And for the parameter, we're going to take in this navigation direction. And actually, I didn't have this have an S at the end. There we go. This navigation direction. Excellent. So now we're just going to make this a quick switch statement here. We're going to switch direction. Wonderful. And we're not going to need the single quotes there. That is not necessary. We're going to do a default here. And essentially this is only going to happen when we pass in center. Can't opposite center, silly person. Okay, so we're just going to, at that point, return navigation direction.center. That will be our default state. Excellent. Now we're just going to need to go through this and tell it which one the opposite direction is. So case navigation direction.north. The opposite here is obviously return navigation direction.south. Super easy. Then we're going to do case navigation direction.south. What's the opposite of that? Well, we just said it. Navigation direction.north. Excellent. Next we're going to do case navigation direction.east, and we're going to return navigation direction.west. Then we're going to do case navigation direction.west, and we're going to return navigation direction.east. Wonderful. Now we're going to do case navigation direction.northwest, and the opposite of that is return navigation direction.southeast. That's the opposite of northwest. And then case navigation direction.northeast would be return navigation direction.southwest. Obviously. And then case navigation direction.southeast would return navigation direction.northwest. And finally, case navigation direction.southwest would return navigation direction.northeast. Okay, let me just make sure that this is correct. North-south, south-north, east-west, west-east, northwest, southeast, northeast, southwest, southeast, northwest, southwest, northeast. Perfect. Otherwise, I will return navigation direction.center. And I think... Oh, I typoed this. This is navigation direction. Opposite. Wonderful. Okay, so now if we want to utilize this, it's as simple as calling something along the lines of, I'm just going to do this here, we're not going to keep this here, but it's as simple as calling position in tile dot opposite. There we go. So that would just return the opposite of that particular tile. Wonderful. So now let's hop over into our tile. We don't need entity open. We're not going to be messing at all with entity today. Although, we are going to do a few changes to our actual tile here. We're going to go ahead and minimize all of these. We don't need to have their initializations open, since those are pretty much done, at least for now. And I'm just going to remove the space between them just to save a little bit of space here. But we're also going to need to rename these. And we're also going to add in a public list of nav node, and that's going to be nav nodes. Excellent. We're going to be needing this list. And let's also initialize this list. So let's just do down here a private void start. And that's of course going to be called by Unity. And we're going to say nav nodes equals a new list of nav node, but we're just going to initialize that list. And that is going to be center, north, south, east, west, northeast, northwest, southeast, and southwest. So that'll just automatically put in all 9 of these nav nodes into our nav node list. Wonderful. So that's a good start, but let's go ahead and rename these at this point. So we're going to rename it utilizing the rename function in Visual Studio. That'll be center node, and this one will be the north node now. This will be the south node. This will be the east node. This will be the west node. This will be the northeast node. This will be the northwest node. There we go. This will be the southeast node. And the southwest node. Wonderful. Now we're also going to need some neighbors in here, and these will be tile neighbors. So I'm actually going to move this header here to be down here. There we go. That's a little more clean. And we're going to make ourselves a new region, and we're going to call this neighbors. We'll end that region for now. We are currently done with the nav nodes region, so we can minimize that. Keep that relatively clean looking. Fantastic. So inside of the neighbors here, we're going to need a public list of tile, and we're going to call this neighbors equals a new list of tiles. And that will be populated in with a function that we're going to add in just a moment. We're going to do a public tile north neighbor. We're going to do south neighbor. We're going to do east neighbor. We're going to do west neighbor. And we're actually also going to need the others. I'll do those on a separate line here just to not have it go quite as far. So public tile, this will be northeast neighbor. This will be northwest neighbor. This will be southeast neighbor and southwest neighbor. Excellent. Okay, we'll go ahead and put a header in here. Header neighbors. Excellent. Okay, now we're not quite done with this region yet. I'm actually going to put a method in here because this is to do with neighbors. Very much to do with neighbors. This is going to be public void add neighbor. And then we're going to take in a navigation direction, and we're going to take in a tile. Excellent. So we'll switch our direction because we need to do slightly different things in each direction. So switch direction, and then we're going to do case navigation direction dot north. There we go. And then we will break that for now. We'll do case navigation direction dot south, and then we'll do the same thing for all of the others. So east and break, and a typo that apparently, and then case navigation direction dot west and break. Wonderful. Case navigation direction dot northeast, break, case navigation direction dot northwest, break, case navigation direction dot southeast, break, and case navigation direction dot southwest, actually. Southwest. Break. Fantastic. Okay, so when we're actually doing this, we're going to need to set our north neighbor to be in tile. Excellent. So that just takes in the tile that we added here, and that is now our neighbor to the north. Now let's connect our navigation nodes here, and keep in mind that the north neighbor is also going to be add neighbored to us. So the north neighbor will receive south and us, because this will be the south neighbor at that point, if that makes any sense whatsoever. So we only have to worry about doing this for our nav nodes, because north neighbor in this situation would be responsible for setting up its own nav nodes. So for each of these neighbors that are the cardinal directions here, we're going to need to set up 3 nodes. In this case, this is the northeast node, and we're going to need to add in a connected node here, and that's going to be tile.the southeast node. So, like, if you imagine we've got a square here, we've got a square here, and we're trying to set up this node here, that would be the northeast node and the southeast node. I don't know how visible that was. I'm noticing that on my actual screen, my cursor is white, and on the recording, it appears to be black, which is different. At any rate, that's how it needs to be. So then we're going to set our north node dot connected nodes dot add. We're going to add in the tile dot south node. Wonderful. And then we're going to need to do northwest. I typoed that. Northwest node dot connected nodes dot add, and we'll do tile dot southwest node, which Visual Studio already figured out, probably because I'm re-implementing this at this point. And this should be tile dot southwest node, actually. There we go. So we're going to do basically the same thing for the other cardinal directions, and I'm actually just going to copy and paste this, and then we'll change the directions. So instead of this being north neighbor, this should of course be south neighbor. And instead of this being northeast node, this should be southeast node. And then this would connect to tile.northeast node. This would be south node, and this would be tile.north mode. This would then be southwest node and connecting to tile.northwest node. Excellent. Next, we're going to... What is this recommending that we do? Oh, it's recommending that we change this. Yeah, that's because it's seeing what we're doing here. But it doesn't quite know how we want to do this. So we're going to say that our east neighbor is equal to the tile. And then our... let's see here. This would be slightly different. We would need our northeast node to connect with the other tile's northwest node here. Here, let me actually just pull up Blender so that I can demonstrate here, because I feel like I'm being a little bit confusing. So let's just pull open our tile set here. There we go. Okay, so let me just demonstrate here. And apparently I hit numlock, but that is irrelevant. I'm going to duplicate this and move this out here so that we don't mess with anything. And then I'm going to duplicate this and move it over 3. Okay. So I'll go into face select mode. So here we are. We've got our core node here, and we're trying to add an east neighbor to it, right? So these 3 are the ones that would be adjacent to these 3. So we want to set our northwest node here equivalent to the other tile's northeast node. So let's hop back in over here, and this would be northwest node. No, wait. That one is to the east of us, so this would be us. So it would be the northeast node connecting to the other tile's northwest node. I feel like this did not clarify. We're going to do tile.northwest node is the one that connects to. Our east neighbor is equal to tile, and that apparently does not exist. Oh, because I typoed it. Okay, there we go. So our east neighbor is equal to tile, and our northeast node connects to that tile's northwest node. This would be our east node connecting to that tile's west node. So again, we are here. This is our east node connecting to this tile's west node. And then our northwest node here is not correct. We would need this to be our southeast node connecting to the other tile's southwest node, which is actually correct. So our southeast node connects to this tile's southwest node. Wonderful. And I'm actually just going to move these apart slightly, kind of like that. Okay. Wonderful. So now we need to do the same thing, but in the west direction. So our west neighbor equals tile, and then our northwest node would connect to the tile's northeast node here. So northeast node, and again, we are in here, and we are now this tile adding a tile to our west. So our northwest here connects to that tile's northeast. Okay, and then our west node, that should be neighbor with a B. Our west node here connects to the tile's east node. And then our northwest node, this should be the southwest node, connects to the tile's southeast node. Let's just verify that here. So we are here. Our tile's southwest node would connect to this tile's southeast node. Yes. Okay. Wonderful. Now for the northeast and northwest and southwest. This is actually going to be slightly simpler because if we grab these and move it up 3, and actually I'm going to move it up slightly more so there's a bit of a gap there, you can see that the only actually adjacent-ish tile, and we are allowing diagonals here, the only actual adjacent node here is these two. So all we need to do here is we need to set northeast neighbor equal to tile. And then, let's see here. This is adding to the northeast, which is actually the opposite of what we've got here. So we can move this over to be about here. And we are here. So then our northeast node connects to that one's opposite node, which is the southwest node. So our northeast node dot connected nodes dot add, and then this would be tile dot southwest node. And that's the only thing that we have to do here for these diagonal ones, since that's the only actual connection. So we'll go ahead and copy this and paste this in here, here, and here. And then instead of this being our northeast neighbor, our northwest neighbor is set to tile. And then our northeast node, this should in fact be our northwest node, should connect to the tile.southeast node. Exact opposites. Because at this point, we are over here. And our tile.northeast connects to this one's tile.southwest. Or rather, northwest connects to southeast. Excellent. I think I did this opposite. This is northwest connects to southeast. Yeah, that's right. Okay. Yeah, I'm just verifying in my head. That is indeed correct. So our southeast neighbor equals tile at this point. And then our southeast node would connect to tile.northwest node. And let's just use our visual aid to verify that. So we're connecting at this point to the southeast, which is over here. So our southeast node connects to this tile's northwest node. Fantastic. Then for southwest, we'll do the same thing. Southwest neighbor equals tile. And finally, southwest node equals tile dot, this should be the northeast node. Let's just verify that. Of course, that is indeed the case. So our southwest tile connects to this tile's northeast tile. Perfect. We're actually going to close this without saving. Don't save, because that was just a visual aid. Wonderful. So that gets us our neighbor and our adjacencies for that neighbor set up. But we should also set up our internal adjacencies. Adjacencies. Okay. We'll come back to that if we've got time this episode. I haven't pre-scripted that one, so I'll have to think about it a little bit, but it's not particularly complicated. But like I said, I think that we will come back to that one in just a little bit. So let's hop over into our map here, and we're going to have quite a lot of work to do in the map. Let's go ahead and create ourselves a region here, and we will call this map updating. And then we will end the region here. Excellent. And for right now, we're just going to minimize that whole map updating region. We don't care about that currently. We will definitely be back to that. But for right now, we're going to work on a region called Map Utilities. Excellent. We're going to end that region. Obviously, this nav node find nearest nav node from position, that doesn't work. We're going to need to make that work. So what we're going to do here is we're going to do exactly that. So we're going to have to iterate through this twice, right? Because we're going to need to find the nearest tile, and then we're going to need to find the nearest nav node. So let's actually make ourselves a separate function for this. Public tile find nearest tile from position, and we're going to pass in vector3 position. Wonderful. And no, I don't want to do on application pause. Thanks, Visual Studio, but that's not necessary. So at this point, we are going to say float distance. We're also going to say float best distance equals mathf.infinity. And then we're going to say tile nearest tile equals null. And then we'll just return nearest tile. We're not done with it, but that's what we'll do for now, so that this actually returns something. Just to get rid of that compiler error. And now we will actually find nearest tile. So the way that we're going to do this is with an overlap sphere. So we're going to say colliders equals physics dot overlap sphere. And the reason we're doing this rather than iterating through our map is because this is going to return a far shorter list. So this is going to be far faster to do this than it will be to compare this on every single map, or every single tile in the map. And we're just going to do this from the position, and we're just going to do this in a radius of 3, which of course is the size of our tile, is 3 units. Wonderful. In fact, I suppose we could do like a public static const float tile size equals 3f. Cannot be marked static because it's const. Okay, yeah, that's fine. So a const float tile size there, and then we can just pass in tile size. And this would be tile.tile size. Okay, there we go. So that's a little bit better. Now we have a way to change that in here if we want our tiles to be of a different size. And we can actually change that on a tile set by tile set basis, potentially. We'd have to make this not be a constant, but maybe that should actually be in the tile set. Yeah, let's have that be in tile set rather than tile. We'll just pop that over there, and public const float tile size. There we go. Okay, so that will get us a list of colliders that are within this area. Now, we don't currently have colliders on our tiles, right? That's a bit of a problem. Let's just search for tile here. Because if we look at these, we will quickly notice... Oh, we don't return a value here. Return null just so that this compiles, so that we can work with this. And the name tileset does not exist, apparently. This is supposed to be... Oh, it's a lowercase s. Tileset.tilesize. There we go, that would help. I was gonna say, that was supposed to be a static reference, but... there we go. Okay, so we'll do tile here, and we're going to search in a project for tile. There we go, and we'll grab these. And you'll notice these do not have colliders on them. We're just going to add a component, mesh collider, for now. And that should automatically fill in from the mesh filter for all of these. Wonderful. So those now have a mesh collider. Now, that's not necessarily going to work the way we want it to. Like if we pull out this ramp here, I think we will find... Yeah, if we make it convex, you can see it does that. If we make it non-convex, it can get complicated. And we're going to have to make proper colliders later on. But for now, we're just going to use the mesh collider here. And you can... Thank you, VLC, but I wanted to remove this. Actually, I didn't want to remove this. I want to delete this guy. Okay, so we're just doing that for now so that they have a collider. But we're going to need to use custom colliders. Oh, hello, desktop. We're going to need custom colliders for the server, and we're going to need basic colliders for the client, rather than mesh colliders. Okay, so that gets us our nearest, or a list of tiles that are within one tile of us. If we're in the dead center, that is likely to return anywhere between... Actually, at any time, that's likely to return anywhere between 1 and 9 tiles. And we need to figure out which one is our actual tile. So we're going to go ahead and iterate through this. Actually, let's check our length first. If colliders.length equals 1, then we will simply return this. Let's see, we return the tile. So we need to do colliders0.getComponent tile, like that. Okay. If colliders.length equals 0, then we need to simply return null and say no tiles found here. Wonderful. And then if colliders.length... Actually, at this point, we don't need an if statement. We can just simply, at this point, iterate through. So we can now say for int I equals 0, I is less than colliders.length, I++. And we are now going to iterate through this. And we are going to now say if colliders I.tag is not equal to tile, then there is no point in continuing to check this collider. This is not a tile. No point in continuing, or no point in checking this collider, as it's not a tile. What is this wanting me? Comparing tags using equals equals is inefficient. It wants us to use compare tag. Okay, fair enough. We'll do that. Thanks, Visual Studio. It should be equivalent as far as we're concerned, but if that's more efficient, go for it. So if it's not equal to tile, then we're going to want to continue. Wonderful. Now, of course, our tiles don't have that tag set up. Let's go ahead and add a tag, and we'll call this tile. Wonderful. And then we'll select all of our tile prefabs here. And we will simply tag them with tile. Wonderful. So they're now tagged with tile, and realistically, we should also say here if colliders 0 dot compare tag tile, if this is not true, then we should simply return null. Because the only thing that we found, the only collider that we found, was not, in fact, a tile. We're only interested in tiles right now. Okay, so if this is a tile, then we are at that point going to say distance equals mathf.abs. So we're going to take the absolute value of position, because we don't actually care about whether this is positive or negative. We just want the actual distance here. So we're going to take the absolute value of position minus colliders I dot transform dot position dot square magnitude. We're not going to do a magnitude call because we don't need to know the actual distance. We just need to compare whether a distance is further or shorter. So we now know the distance, or the square distance. If distance is less than best distance, then we can say nearest tile equals colliders I dot get component of type tile. And best distance equals distance. Wonderful. Okay, so at this point, we can simply return nearest tile. This gets us our nearest tile to this position, at least within the size of tile size. Excellent. So at this point, we can just verify. Yeah, we're checking to see if it's a tile. And I mean, technically, if it's marked as a tile, but it shouldn't be, this will still return null. So it'll still return basically the same thing. But excellent. So this will now get us our nearest tile. And we can go ahead and minimize that for right now, because in our find nearest nav node from position, the first thing that we need to know is our nearest tile. So we're going to say tile nearest tile equals find nearest tile from position. We're just going to pass in position. Excellent. And then we should probably say if nearest tile equals null, no point in continuing, we didn't find a tile. So we'll just return null. Okay. And we're not going to return null anymore at this point, because we can go ahead and declare ourselves. This is going to be basically the same thing that we did before, actually. We're going to declare ourselves a float distance, as well as a float best distance equals mathf dot infinity. Wonderful. And now we are also going to say nav node best node equals, and we're going to say nearest tile, which we know there is one because of this check, nearest tile dot center node is the one that we're going to pick by default. And then we're going to return best node. And then we're going to iterate through all of the nodes in the tile in the same sort of way. So for int I equals 0, I is less than nearest tile dot nav nodes dot count I++. We're now going to say distance equals mathf dot abs, basically exactly the same thing. Position minus nearest tile dot nav nodes I dot position dot square magnitude, like that. What did I miss here? A starting parenthesis. Okay, there we go. Now we're going to say if distance is less than best distance, our best node is equivalent to nearest tile dot nav nodes I. Excellent. And our best distance is equal to distance. Okay, and once we finish the loop, we know that we have our best node, so we simply return our best node. Wonderful. So there's our find nearest nav node from position and our find nearest tile from position. Both of those are now complete. And so we are going to need to put in a couple more methods here. These are going to be still pretty handy utilities. Like, for example, one thing that I thought of for this, what we're going to, actually, let me back up. What we're going to implement here is a getDirection series of methods where we can put in either a tile, a nav node, or a vector3 and figure out what direction it is from a different tile, nav node, or vector3. And realistically, we might want to create several overloads for this, but for right now, well, yeah, we probably do want to create several overloads for this. So what we're going to do, or actually, let me back up again, because I wanted to say one of the things I was thinking about is, what if in your quest log on your screen, it told you what direction your quest was, but it didn't really give you much guidance other than that. So it would be, for example, kill 10 bears to the north. And you continue, as you go north, if you pass it, maybe you passed it on the on the east side of it. So then it says, kill 10 boars, or bears, or whatever it is, to the west. So the log just updates with a kind of textual compass. That's something that we could do with this. So first, let's start implementing these methods. So we're going to do our base method first. Public navigation direction getDirection. And that's going to be vector3 from and vector3 to. Nope. I always do that. Okay. So we're going to create a new vector3. We're going to call this diff, and that equals to minus from. Excellent. And now we're going to need a series of if statements. So if diff.x equals 0 and diff.z equals 0. Again, we don't care about the y values. Then we are just going to say from and to are equivalent. We're going to return navigation direction dot center. We're basically right on it. In fact, we're literally right on it. So that is fine. Next, we're going to say if diff.x equals 0 and diff.z is greater than 0. Greater than 0 in the z is our northern direction. So we will simply return navigation direction.north. We'll also do an else statement here just to keep these kind of bunched together. If diff.x is still equal to 0 and diff.z is less than 0, that is, of course, our southern direction, so we will return navigation direction.south. Excellent. Now we'll do the same thing for east and west. If diff.x is greater than 0 and diff.z is equivalent to 0, then we will return navigation direction.south. Hang on, what am I doing? This is navigation direction.east. There we go. Else if diff.x is is less than 0 and diff.z is equal to 0, then we will return navigation direction.west. Wonderful. Next, we are going to do if diff.x is, let's see here, this should be, at this point, north. This should be northeast and northwest. So if diff.x is greater than 0 and diff.z is also greater than 0, then we should return navigation direction.northeast. Because at this point, we're north because we're greater than 0, and we're east because we're greater than 0. Excellent. Else if diff.x is less than 0 and diff.z is also less than 0, then we will return navigation direction.north. Rather, this would be navigation direction dot... should also be greater than 0 in the z direction, actually. There we go. If diff.x is less than 0 and diff.z is greater than 0, then we return northwest. Excellent. if diff.x is less than 0, actually if diff.x is greater than 0 still, and diff.z is less than 0, then we're in the south direction. So we can say return navigation direction dot southeast, because diff.x is greater than 0. Else, we've exhausted every other alternative. We don't need to check anything else. We know that this is southwest. So we can return navigation direction dot southwest. Excellent. That's a lot. But that's also our base function. Everything else is going to refer to that and is just going to be one-liners. So we are just going to do something along the lines of public navigation direction get direction. This is going to be an overload for tiles. So tile from and tile to. Excellent. And this is going to be return get direction from.transform.position. I spelled transform wrong. Form.position and to.transform.position. Wonderful. And now we'll do another one. Public navigation direction. This is going to be get direction, and this is going to be nav node from and nav node to. Excellent. So we will simply return get direction, and we're just going to take the positions of the nav node, so from.position and to.position. Wonderful. Now let's create a couple more of these overloads. Public navigation direction get direction. This is going to be, say that where you want to go from a tile from, and go to a vector 3 to. That's fine. Return get direction. This is going to be from.transform.position, and this is just going to be 2. And let's flip that around. Public navigation direction get direction. This is going to be vector 3 from and tile 2. Same thing here. Return get direction from and to.transform.position. Wonderful. And we can just create as many of these variants as we want, essentially. So that's both for tile and vector 3. So next we're going to do both for nav node and vector 3. So public navigation direction get direction. This is going to be nav node from and vector 3 to. We're going to return get direction from.position and to. We'll do the same thing again. Public navigation direction is going to be get direction, and this time it'll be vector 3 to and nav node from. And we'll simply return get direction, and that will be from and, let's see here, this is to.position. Excellent. So that's every variant of tile and nav node with vector 3. But now we need tile and nav node with each other, so we'll just do that quick. Public, what did I do wrong here? This should be from.position and to. So now we'll do a public navigation direction. This is going to be get direction, and we're going to do tile from nav node to. And we're going to return get direction from dot transform dot position to dot position. Wonderful. And one more. Public navigation direction get direction. And this overload is going to be nav node from and tile to. Excellent. Return get direction from dot position and to dot transform dot position. Excellent. So that's all of our variants there. That's a lot of variants, there's no doubt. But we can just minimize all of these like so, and we can even create ourselves a bit of a sub-region here. And so we shall. Region get direction. Overloads. we'll end that region. And this is now a sub-region inside of map utilities. Excellent. Okay, so that gets us all of that. Now, as I was saying, we can set up our internal adjacencies here. And I think we probably should. So, let's see here. How do we want to do this? I haven't actually planned this out. This could get really, really messy here if we don't do this correctly. I'm going to actually minimize this add neighbor because that's kind of large. So our internal adjacencies here are indeed going to be slightly awkward. So we could do something along the lines of center node dot connected nodes dot add. The core issue here is that we will have to do this, we'll have to call this 8 times. Because this just has an overload. We could do an add range. And that would be an IEnumerable collection. We might be able to do new nav node array and pass it like that. Yeah, we actually could. That would clean it up maybe a little. North node, south node, east node, west node, northeast node, northwest node, and then we'd bring this down, and we would just do something like southeast node and southwest node. Okay, so that would set up the adjacencies for the center node for the internal adjacencies. Keep in mind this will not set up the adjacencies externally. That's what the add neighbors function does. Okay, I do want to do one more quick thing before we get back to this though, and that is that I want to, in the map utilities here, I want to do a public void assign neighbor, and that will take in tile A and tile B. Excellent. So we're going to get the direction from A to B. Actually, I'll do it like this. From A to B. Navigation direction equals get direction A, B. Wonderful. Next, we're going to say a.add neighbor in that direction, and the neighbor is B. Then we're going to say we need the opposite direction for B to A, and I kind of don't want to just go through all the calculation again. It's probably slightly faster to just use our opposite function, and it's certainly easier. So we'll just say b.addNeighbor, and this is going to be direction.opposite, and then we'll pass in A. Wonderful. So if we pass it in for A to add B as the east here, then A adds B as its east neighbor, and then B will add A automatically as its west neighbor. Fantastic. Okay, so let's go back to tile here. We have our center node adjacencies set up. So let's just go through these. North node.connectednodes.addRange, and we're going to do a new nav node array. And this array is going to be, let's see, this is the north node. So this is going to, let's actually pull back open the tile set here. And we'll take a look at this guy. So we're currently working on this node. So we need northeast, northwest, center, east, and west. Okay. Northeast node, northwest node, center node, and then this would also be east node and west node. Fantastic. And actually, let's go kind of clockwise from northwest node. .connectednodes.addRange, and we're going to do new nav node, and we're just going to do that. Excellent. And now I'm just going to copy this. So that's 1, 2, 3, 4, 5, 6, 7, 8. That's how many we should, in theory, need. And this, instead of being the northwest node, would be the northeast node. This would be the east node. And then this would be the southeast node. This would be then the south node. This would then be the southwest node. And then this would be the west node. Okay. So, for the northwest node, we need to add in the north node, the west node, and the center node. Okay. North node, west node, center node. Wonderful. For the northeast node, we need to add in the north node, the east node, and the center node. Okay? North node, east node, and center node. For the east node, we need to add in the north node, south node, the northeast, southeast, and center nodes. So we'll do center node, north node, south node, northeast node, and southeast node. Excellent. And I'll actually get rid of this line as well. Okay, for the southeast node, all we need is the east node, the south node, and the center node. Center node, east node, south node. Excellent. For the south node, we are going to be needing the center, the east and west, and the southeast and southwest. Center node, east node, west node, southeast node, and southwest node. Excellent. For the southwest node, we just need the south, the west, and the center. Center node, south node, and west node. And then for the west node, the final one that we need here, we need the northwest, southwest, north, south, and center. Okay. Center node, north node, south node, northwest node, and southwest node. Excellent. So that should set up our internal adjacencies within the hex itself, and then when we add the neighbors, it should automatically set the adjacencies with the neighbor accordingly as well with the nav nodes. So that should all get completely automatically set up for us as we spawn in the map, which will be in the next episode. So that gave us a bunch of map utilities to work with. And the next episode will be map spawning. Excellent. And with that, I'm going to go ahead and put a cut in here. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.